Translations are the first in a series of these things called transformations. And a transformation changes one figure into another. The new figure is called the image. And the one that I said we're going to talk about today is called the translation. And as you can see in the picture, it's taking one shape and sliding it and then creating a new shape. So it's kind of like the old shape, just in a different spot. And a translation is also known, as it says, as a slide. And translations form congruent figures. So you can see that these two shapes have all the same lengths of their sides, and you can see that their angles are all the same. And so we learned in the last lesson that's what makes things congruent. So in order to identify if something's a translation, you just have to look to see if it was slid across the page. And if the only thing that happened to it was sliding, then it is a translation. So let's go from left to right. Or I'm sorry, the figure on the left is a translation of the figure on the right. So this is really the original and this is really the image. So we're going from this red one to this blue one. And yes, the only thing that happened was it slid down the paper. So this is a translation. And the one over there in letter B, it could have been slid, but it was also turned, which we'll talk about in another lesson, but this is not a translation. The way that you create a translation on the coordinate grid, which is what we're really going to be concentrating on, is by doing the following things. In order to move, let's say we're starting with the red shape and we're going to the blue shape, and I'll explain what those little dashes mean in a second. But in order to go, for example, from point A to point A over here in the blue shape, you would have to move it this way and then move it to the right and then go down. But the way that you mathematically move that is you add to the x value in order to move horizontally. And you would add to the y value in order to move vertically. And remember that horizontally goes this way and vertically goes this way, up and down, and horizontal is across. In order to do that in algebra language, to write what I just wrote in fewer symbols, I'm going to start with this point x comma y, and I'm going to turn it into this point x plus a, y plus b. And a and b are just random variables that I'm using to represent certain numbers that I would do. So for example, if I wanted to move it 5 horizontally and 2 vertically, I would do x plus 5 and y plus 2. Now, you should be saying to yourself, wait a second, what if you want to subtract? How does that work out? And as you should remember from 7th grade, adding a negative is the same as subtracting. So I'm not going to put that down because that's a more specific example. But if you want to move to the right or up, it's going to be a positive. If you want to move to the left or down, it's going to be a negative. So these are the two different times when you might want to decide whether you're going to add or subtract. Left and down, just like the number line, is negative. Now let's talk about these little dash things over here. And the way that you would read this point right here, you wouldn't read it as a dash, you would read it as a prime. And that's how you know, and then this would be b prime and c prime. And that's how you know which one is the original and which one is the image. Because if I just call this A, B, C, then when I say look at point A, you say, I don't know, which A are you talking about? Are you talking about the A over here or the A over here? So you put this little apostrophe thing, which we call a prime, in order to tell our reader this was the original and this was the image. And if you don't put the primes, listen very carefully, if you don't put the primes, you are wrong. So please put those primes, because then you have 2 point A's competing against each other, and then they have to fight it out, and one of them has to die, because you can't have 2 A's on the same coordinate grid. It's just, the universe would explode. So please remember to put the primes on any time you do a translation. Speaking of, let's do it. So we have to translate this triangle that we see right here, 3 to the right and 3 units down. Now, since they give it to us in words, we don't have to do that algebra notation. We can just do it by counting boxes. So I'm going to take each point, and I'm going to go 3 to the right and 3 down, and then this is where I'll put point J. I'm sorry, not J, J prime, because it's the image. Now we'll go to K. 3 to the right, 3 down, and then K prime, and then L, 3 to the right, 3 down, that's L prime. Now if you've done it correctly, you should see that the shapes are congruent, same shape, different size. I'm sorry, same shape and size. Angles and sides are all the same. And you should, although I'm not going to be a stickler about it, but in class I will, you should be using a straight edge to make these lines. You should not be wiggling it. If it's wiggly, I will make you do it over. But if it's pretty straight, that's okay. And we have to finally state the coordinates of the image. So J prime is 2, 0. K prime is 2, -2. And L prime is at -1, -2. And that's all we have to do. Why don't you see if you can do example 3 on your own? You have to draw the square first, then draw its image, and you don't actually have to state the coordinates. So you just have to draw the figure and its image. So pause the video, and when you're ready, play, and I'll pop up the answer. All right, so here we go. I hope you remembered to do those prime markings. And just so that we're all clear, I am going to write what the coordinates are so you can match mine. Even though it didn't say to, I'm going to do it for you so that there's no question about where you were supposed to land. So A prime is at -3, 4. B prime is at -1, 4. C prime is at -1, 2. And D prime is at -3, 2. Last thing I just want to point out, because we didn't use the algebra notation at all, where we added or subtracted, I just want to show you what would happen. So we would subtract 4 from the x, and we would add 6 to the y. So let's see what happened. 1 minus 4 is -3. -2 plus 6 is 4. 3 minus 4 is -1. -2 plus 6 is 4. So you see, you could have also created the coordinate points without having to draw the shape. And if you want, I'll do the same thing for C and D. 3 minus 4 is -1. -4 plus 6 is +2. 1 minus 4 is -3. -4 plus 6 is +2. If you have any questions, write them down and ask me when you see me next. It doesn't matter whether you use the counting boxes or the algebra technique. You just want to use whatever technique is easiest for you for that particular example.